Just to introduce myself, I usually just like to say that I'm someone who's genuinely passionate about demand forecasting and inventory optimization. I'm hosting a huge blog about it, so you have the link there. I'm just about to publish my third book on a subject. Actually, I think the ebook is already available, so you could already go online and buy it, and the printed version should be out. I think it's going to the printing machine in the following days, or it might be in just 2 weeks. It should be out pretty soon. So I'm writing on my blog, I'm writing books, I'm also teaching at university. Nowadays, I'm mostly teaching in Paris, France. So if you are in Paris, France at any point in time, just let me know. We could at some point meet. So that's for my big passion and hobbies. Professionally speaking, I'm a consultant. I founded my own consultancy company, and I'm helping companies basically to improve at demand forecasting and to optimize their inventory. I usually train people, train professionals. I coach professionals to make their own models, or I simply develop models for companies so they can get them as fast as they can. Fun fact, I'm actually a big fan of heavy metal. So if you read any of my content, you can safely assume that I wrote that listening to metal music. That's nearly for sure. So as a professional, my type of clients would be very big international companies, such as the kind of companies you can see there. And I said I would train these guys, coach them, or directly create models for them. That's it for me. Let's go to the topic. I will just assume that the audience to this specific webinar today, most of you data scientists, you know what machine learning is, you know what Python is, but you're not experts in supply chain, you're not expert in demand forecasting. So I will treat the audience as such and try to guide you to, okay, let's just assume you know Python already, you know machine learning already, or R maybe, and you want to apply this to forecasting demand. How should you do that? Well, the first question, and I think it's super important, so that's why I'm starting with it, and I'm always starting with this one is, but why do we do this? Why do we forecast demand? And I think it's very, very important as a data scientist, you go to business, and the first question you should ask yourself is, when I make this model, like why are we just doing this one? For demand forecasting, the answer is, if you take a supply chain or any kind of business organization, they need to make so many decisions every single day. A decision could be how much to produce, how much should we ship, what should we produce, should we close or open a warehouse, a factory, these kind of decisions. Now, when you make a decision, you want to have the best possible piece of information so you know what you should do, right? So to be very concrete, if you want to know how much of a product you should produce, if I give you as a piece of information, this is the exact, very precise forecast for the next month, that would help you a lot to really know how much to produce, okay? So when we forecast demand, we have to keep in mind that we only do this to help other people to act, but we, as the forecaster, or in supply chain, we call that demand planners, we are not decision makers. That would be other people. We just provide information to them. By the way, on each slide, I'm showing the icon of the book. If you're interested in a topic, you just look at the icon, and that would tell you which book would go deeper on this specific topic. Now, there is a concept that's very important for me. It's demand planning excellence. You could just read this as forecasting in supply chain excellence. It relies on two things. First thing, we want to have forecast that supports decision. Okay, some people would say we want to have accurate forecast, but for me, accuracy is kind of a byproduct of the forecast is useful. Okay, so the main objective is that the forecasts are useful, and usually it means that they're accurate, but you could make very accurate forecasts that are not so helpful. Okay, that would be for another webinar, but for now, I'd like to focus just on this is useful. The second thing, which will not be the main topic today, is efficiency. Basically, if you manage a team of forecasters, of demand planners, you don't want these guys to work too much. You want them to focus on the few products that really matters a lot. Okay, you don't want them to go through a file of 10,000 products, 1 million products. No, you want your team to focus on just a few very important products. How do we get there? So I created this kind of 5-step framework, and that's basically the topic of my upcoming book. It's basically just to go through these 5 steps. And today we will just highlight some part of these, but I just follow, and I always follow these 5 steps. So the first thing is that we need to define what's the objective, why do we forecast demand, and what should we forecast. Then we can discuss how do we get the data to support these forecasts. We can then assess how do we measure forecasting accuracy, what kind of metrics should we use for these forecasts. And then, and only then, you can start discussing, okay, how do we make the model? But I will never start with, let's make a model, and then we can discuss how do we use it and metric. No. First, you discuss what you should do, what kind of data you should use, what's the right metric, and then you can start working with the model. And finally, and that's out of scope for today, we can discuss how do we review the forecast with your team. But that's a very, very important subject for supply chain people. Okay, let's start with basic stuff. When you make a forecast in a supply chain, as said, you are not a decision maker. You are someone who's looking at the horizon and trying to get information about what's lying ahead, what's in the future, and you're giving this information to other people in your supply chain. So it's very important to see yourself as a forecaster, as someone who's looking at the horizon, trying to get information, and then you give this to other teams. Something that's important here is the concept of unbiased. As you're not a decision maker, you should not be on the safe side, or you should not be aggressive with your forecast. You should be as unbiased as possible. Okay? If you see something, say something, but don't overstate it, don't understate it. Just say it as you see it, and then other people can decide to produce a bit too much or not produce at all, not to take any risk. Okay? But you have to leave this decision for other people. And hopefully they make the right decision, but that would be a totally different topic. Now, when we discuss data, and it's a very, very important topic, because if you, as I understand, some of the audience are PhD students or people straight out of college or university, we always have the assumption that data is very clean. And then if we receive a data set, at worst, like the teacher or professor will just make one line wrong and we just have to spot it. But when you go to real supply chain, it's much more chaotic than that, and it's at times total chaos. So to boil it down to the main, most important points, the thing that we all have to understand regarding supply chain is that there is a big difference between demand and sales. I like to call that unconstrained demand and constrained sales. So unconstrained demand, or demand, short, would be, that's the thing that the client really wants. And if you could interview every single of your clients, they would say, okay, me, I want this very specific product. But then they come to your store or to your warehouse, whatever, and you don't have the product. So they might buy something else instead, or they might just go home. Okay, that would be sales. But maybe you have enough inventory and that demand is going to be translated into sales simply because you have enough goods. Okay. So it could be that you have a very high demand for a product. So you have a lot of clients coming to your store who wants to buy this. Great. But you have no inventory. So sales drop to zero. Okay. That's something that you really need to pay attention to. Now, let me show you an example so it's very clear for everyone. This is a real data set from a store on Amazon, I think. I don't remember exactly. But you see the sales are very high as long as we have inventory. And when inventory drops to zero on Amazon, then sales drops to zero as well. Okay, that's a big issue. Now, with these stores on Amazon, the issue is that as soon as your inventory drops to zero, Amazon will not promote your product anymore, and then no one will buy it simply because people don't see it on Amazon. Okay, so if you want to forecast this, you might have an issue because it's full of zeros that are all wrong. So here, for example, I made a very simplistic forecast, just looking at historical sales to predict future sales, where it doesn't work. Okay, we see here that we have an issue, and basically we get this kind of wrong forecast simply because we have all these shortages. So we'll have to find a way out of that. I'll show you this in one slide. There is something else to pay attention to. So every business is driven by things that I call demand drivers, such as pricing, marketing, promotion, shortages, these kind of things. Could also be the weather. Now, depending on your supply chain, depending on your business, or even depending on the product, these might be different. But you, as a data scientist, as a forecaster, you should do your best to go and get this data. Now, this is the very critical point. I have a lot of prospects, a lot of clients who would tell me, yeah, Nicolas, we do promotion and we change prices and this impacts demand. Okay, great. Do you have data? No, we don't have data about it. Okay, then this is it. We cannot use it in the models. There is no point in discussing further. We just have to rely on just using the data we have. And I've seen a lot of supply chain that don't track promotions, they don't track shortages, they don't track pricing. So it's actually, in theory, very nice to do a model with that. But in practice, you might face a lot of cases where you have none of this data. Okay. I'll go back to this question of shortages. I decided in this webinar, as you can imagine, I have a lot of things I could talk about, and I decided to just cherry pick some of the most important subjects for me. And I think this question of shortage is the most important one in a supply chain. So here I want to go back to this very same problem. So we have at least two issues. First issue is that if we create a forecast model, and we have this period with 0 sales, and the model look at this thinking, okay, we really have no demand, so my forecast is decreasing, your forecast will be very wrong. And you see this on the gray line that the forecast is kind of decreasing each time we have a shortage. This is really bad. There is something else that's quite bad. Is that actually, if you make a forecast, let's imagine that during this period without any kind of sales because of the shortage, you come to me and you make a forecast like, I think I can sell 20 pieces a day. I'm your manager. I look at the sales and see, you know what? The real sales is just 0 and you forecasted 20 pieces. So your accuracy is 0%. You're the worst forecaster ever. That would be the case for you, but that would also be the case for your model. Your model also would, maybe if your model is really good, the model would forecast 20 pieces. Real sales is 0, accuracy 0%. This is the worst model. So we have an issue. We have actually two issues. How do we solve that? Yeah, I just said that. Yeah, there is even something worse. People, and I've seen this many times, try to hack the forecast. So let's imagine you have a team of planners who are responsible to create forecasts and to review forecasts of your models. And let's imagine that as an HR policy, you want to give them a bonus if they do a great job. So what you would do is that technically, if they improve the accuracy of your model, you would give them like a bonus, a cash bonus at the end of the year. Now, these people, if they're a bit smart, they know that once there is a shortage, sales will be 0. And that's a very simple way for them to improve your forecast. So what they would do is just try to find all the shortages in your product and change all your forecast to 0. So that it would look to you like they did a great forecast. Whereas actually, this does not create any kind of business value. Okay. So we have an issue here because our models are wrong. We don't really know the forecasting accuracy and people can hack the forecast. So it's really, really bad. Shortages are very bad. How do we solve this? The easiest way to solve that is actually just to bypass these periods and just assume that as we don't really know what's happening during these days where we don't have any inventory, we're just going to go through it. We will just not look at forecasting error there, and we will not update our models anymore. So as soon as we have a shortage, it's really like we're just going to bypass the whole period. And that's something very important that we can do with most models. Now, unfortunately, most software vendors don't do that. And most models, even though they could be upgraded to do that, don't do it by default. So that's something that's not yet a common practice in supply chain. So if today you're a data scientist watching this and you want to improve the world, I would say try to upgrade your models by just bypassing these periods. I'll just stop 15 seconds so everyone can think about it. And I'll move on to the next topic. So, real life situation. On the right side of the screen, I changed topic. I'm going to discuss metrics now, which is the second topic that's very important. On the right side of the screen, you can see the time series of the sales of a real product from one of my previous projects. And I created for that 3 different forecasts. It's quite simplistic. You'll have to excuse me, but we'll just use these for this small scenario. So let's imagine you are a demand planner, a forecaster, or a data scientist, and your objective is to decide which is the best forecast. So I want you to think about it, and just for you to pick what's your favorite forecast. Which one do you think should be highlighted as being the best? You could, for example, imagine that forecast 1 has been created by an external consultant, forecast 2 is your current software, and forecast 3 is the forecast made by the sales team. See, so that would be a very real scenario where you have to compare different forecasts and you have to tell me which one you think is the best. Take a second, think about it, look at the graph and try to think which one would be the best. Now, what I propose is that we'll do a vote online where you can say which one is your favorite forecast. To participate, you just have to scan this thing with a smartphone, or I can send you a link. Just give me a sec, I'll do that. Just a sec, I'll try to copy the link here. No, can I copy this link? I'll try to put it on the discussion. Should work. Okay. I see 57 people, so it should work. It's really for free, so you can just go there to vote. Let me give you some extra information about these forecasts. So you will have to trust me on this one, but I computed different forecasting metrics for each of these forecasts. So you can see that on the graph. I computed bias, MAE, MAPI, RMSE, and I show you the result over there. The best one are in green and the worst one in red. And now let's take a vote. You can just vote for your favorite forecast. And we have more than 100 people participating. So normally, if I would give this class live or at university, I would pick some of you to try to explain why you would go for forecast 1, 2, or 3. Now, as we're a bit short of time and I have so many things that I'd like to share with you, we will not have the time, but just try to think for yourself why you would go for forecast 1, 2, or 3. And poor forecast 3 only gets 2 votes. That's really a pity. Okay, it looks like we have a very strong green team today. That's interesting. And we have a very, gray forecast only gets 2 people. That's really strange. Okay, here we see the graph in big. So if you want to see it one last time. So far we have a lot of people going for green, a bit fewer people going for orange, and there is no one going for gray. Let's try to discuss what's happening here. So I wanted to show you that depending on the forecasting metric you decide to use in your model, you would pick a different model. And with machine learning, it also translates to the fact that if you decide to go for a different objective function for your model, you would get a drastically different forecast. So typically here, if you had created any kind of machine learning model and you said, please update MAE, you would get forecast number 2. If you said, well, please update, improve for RMSE, you would get forecast number 1. And if you say to your model, please minimize MAPI, you get forecast number 3. So it's very important to realize that as a data scientist, if you choose another error function, you would get another forecast, okay? A very different forecast, actually. So which one is the best? It all boils down to what are the pros and cons of each of these metrics. And I think I have this on the next slide. Yeah. Yes, do I? Yes. First thing we need to discuss is bias. So as I told you, when we create a forecast, we want to show to the rest of the team future information so they can make a decision. But as I said, it's very important, it's unbiased. You don't want yourself as the forecaster to go on the safe side or to be a bit more aggressive or conservative with your forecast. You're going to leave this to whoever is responsible, whoever is in charge to make the decision. You, as the forecaster, your job, it's a bit like a journalist, you need to provide unbiased information so your colleague can make decision. So your forecast should be unbiased. We already see that forecast 2 and 3 are heavily biased. This is super bad. In a supply chain, that would drive massive issues such as your warehouse or plant being way too large or way too small. This will never work, okay? So the simple fact that we have such high biases makes it basically irrelevant. So forecast 2 and 3 should not be used. Now, something that might have confused you is the fact that forecasts 1, 2, and 3 are the best in different metrics, right? This is very confusing. I made this exercise on purpose, obviously. And you see that forecast number 1 has a very good bias, but it's the worst in MAE, worst in mapping. And that's the big confusion here. Let me try to explain that. I just assume that you're a bit good with math and data science. RMSE as a metric is aiming at forecasting average demand. So by definition, looking for improving RMSE result in having no bias. This is great. Now, MAE is aiming for the median demand, which is not the same as the average demand. Now, the issue with looking for optimizing for the median demand is that in such a data set, the data set is very skewed. So you will have a big difference between the average demand and the median demand. Now, if I compute the average and median demand on this data set, you would get drastically different value. By the way, forecast number 1 is just the average demand, and forecast number 2 is just the median demand. And that's why I have such a variation, okay? Now, MAPI is the worst KPI ever. I've been saying that for years. I've been proving it many times, and this is just another illustration that following MAPI will give you the worst forecast possible. You would get forecast number 3. MAPI is trying always to aim for a very low value in terms of forecast because it doesn't want to take any kind of risk. So I would always avoid using MAPI. MAPI is the worst KPI. Now, don't get too afraid or excited if you think that currently your company or your project is using MAPI, because there is a lot of confusion concerning naming convention in supply chain KPI. So it could potentially be that some of your colleagues say that they use MAPI, but technically they use MAE or they use even something totally different. So actually, I would spend more time looking at the real math and the formula and how KPIs are computed than discussing the names, okay? So again, it's very important that you check exactly how things are computed rather than discussing naming convention. I went very quickly on this KPI. If you want to have more information, I posted many articles on this KPI. You can find them on my blog, but also you can just take a look at the books. It's explained in detail over there. Now, with these metrics, you could say they all have their pro and con. And RMSE, it's good because it's unbiased. That's something that we just saw, but it's also very complicated to explain to supply chain colleagues. And we actually want to explain forecasting error in a very simple way. RMSE is also very sensitive to outliers. And as said, in a supply chain data set, it's going to be full of outliers. So using RMSE might not always be the smartest idea. RMSE has another issue. It doesn't scale well to big data sets. So if you have different products with different average demand, using RMSE across all these products will result in a lot of issues. So actually, RMSE is not perfect. MAPI is really bad, as we just discussed, and MAE is also very biased. So we have an issue here because we don't have a perfect metric that we could just use and right away know which forecast is the best. So yeah, first, MAPI is the worst. I think that's clear. Now, a good compromise is actually to look at both MAE and bias together. And I love this because it's very easy to explain to any supply chain person that we're going to look at accuracy and we look at bias and we want our model to be good on both sides. Okay, so it's a good compromise. I'll just show you how I would do that on this table. So look here, I just summed up MAE with the absolute bias and I get the numbers here. And if I do that, it's extremely clear that forecast number 1 is winning by a massive margin over forecast number 2 and 3. So this MAE plus bias, I like to call it forecasting score. Some of my clients call it the Van der Put formula, but I use this over and over in every single project. When I want to assess my own accuracy, the accuracy of my model, I will always use this score, which is the combination of bias and MAE. Recently, I tried to assess how useful optimizing the score is to improve inventory, and there is a very good direct relationship. So it really means that if you can reduce the sum of MAE and bias, you get to better inventory as well. So it's directly connected to business improvement. I said it's a good compromise. It means that we could go a bit further. It also means it's not perfect. I'm well aware of that. There is no perfect KPI. I will not discuss how to improve that further in this webinar because we don't have the time. But basically, the idea would be to take into account the value of the product. Again, if you want to have more information about that, you can just take a look at the book and you would get a lot of discussion about these KPIs and how to select the best one and what would happen if you use one instead of the other. Let me continue a journey now, and now let's take a bit of time to discuss machine learning itself and how to use it. As a data scientist, I think there are only two things that are important in data science with machine learning: which feature you use, and then how you fine-tune your model. Okay, all the rest for me it's basically detail, and already fine-tuning the model for me it's already a detail. So the only real question is, what are the features? So in supply chain forecasting, I like to say that you don't need to be a data scientist to select features. As soon as you have a community of people, managers, planners, and you just try to explain them what a feature is in machine learning, they can all take part in the discussion. So everyone feels they're involved in this process of creating the model. Now, when you forecast demand for a product in a business, as a human, if I had access to information, I would ask, what's the price? What was the price maybe yesterday? Are you running a promotion? Is it very common for you to run promotion? What was the forecast? What was the sales, a month ago, 2 months ago, the average sales last year? These kind of questions, right? If you want to predict the sales of tomato in a supermarket tomorrow, you will most likely ask yourself this question like, how many tomatoes did you sell yesterday? What was the weather like yesterday? What's the weather like tomorrow? What's the usual sales price for tomatoes? These kind of questions. So as you think about these kind of questions for yourself making a forecast as a human, you can safely assume that your model will want to look at the same pieces of information. So here's an example. I just took it out of my training class. Basically, I would just say, if you want to forecast future demand for a machine learning model, you just have to look at historical demand, historical prices and promotion, as well as future prices and promotion. If you have these kind of features in a model, I think you already did 80% of the work. Now, what's going to be very difficult is to create such a data set, to gather data, to clean data, to make sure it's correct, and so on. This might be the biggest change. Optimizing the model itself, for me, that's the detail. Okay? I'm sure we can rediscuss that during the Q&A right after. Now, when I introduce this in companies, a very important question, and that's totally normal, is, okay, but what can we expect out of that? Okay, that's great, machine learning, that's maybe a fancy word, maybe there is some hype about it, but is it really good? Like, can I expect anything out of that? So we have international competition of forecasting, and since 2018, we had 3 main forecasting competition regarding supply chain and businesses. All of them have been won by machine learning. So there is nearly no way, no hope that you could go to such a competition with the statistical model and win these. Basically, if you look at the top 10 or top 20, there is no one using a statistical engine. Everyone is using machine learning. Okay. I show on the left side of the screen some information on these. There is something that I'm not so happy about, is that every competition is using a different benchmark. So it's very difficult to say exactly how much added value we get from using machine learning because the benchmark are not consistent. So I could not really tell you, okay, based on the very same benchmark, we always make this much improvement. Nevertheless, I said, if you look at the top 20 competitors, it would always be machine learning. On my personal experience, and I published detailed case study about all of these cases, I see that using machine learning with the feature we just talked about, we can beat a benchmark such as a good moving average by 20 to 30%. And usually we can beat statistical model by 0 to 20%. Okay, so that's the kind of forecasting accuracy improvement you could get by using machine learning. What I see is that overall, if you have more information, you get higher accuracy. So if you have information about pricing, promotion, shortages, marketing, these kind of things, the weather, you get higher accuracy. But also if you start forecasting per week instead of per month or even per day, you also get higher accuracy. It's very simple to understand that, I guess, for you. More information means more accuracy for your model. I'm just thinking if I had something to add here. Yeah, something, and I didn't make a slide about it, but that's very important. When you make a model, you should always compare it to a benchmark. Most data scientists don't do that. In the world of forecasting, in the past, many people would advise use a naive forecast as a benchmark. A naive forecast is simply saying, my forecast for tomorrow is basically how much I sold today. So the forecast for June is the sales of May. But that's too simple to beat that. Beating this does not mean anything. Instead, I realized that a benchmark that's quite difficult to beat is a moving average. Just 6-month moving average, it's quite difficult to beat. And I actually realized that most software companies and big software vendors that are specialized in forecasting actually don't beat it. So it's very likely that if you start your career tomorrow in a company that says, well, we're using these kind of very big software companies and made a forecast engine, optimization, blah, 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 you can just compare that to a 6-month moving average. And it's quite likely that you can beat it already, or just be 1 or 2% off from their accuracy. So it's very impressive. So you have to imagine with machine learning, you can decrease this by a further, I would say 10 to 30%. Okay. Now, as a recap, you want to use machine learning to forecast demand. First thing first, you have to set yourself an objective. What kind of metrics you want to optimize? What's your forecasting horizon? We didn't discuss this much. What's the granularity? Then you start collecting data. The most important one is try not to get sales data, try to get real unconstrained demand data, or to look at shortages to bypass period where you had a shortage. This is the most important thing. In the end, if you only keep one thing from this webinar, let's be this very specific thing. After this, you also need to collect demand driver, pricing, marketing, promotion, these kind of things. Again, I know that data cleaning, data gathering, it's not sexy, it's not exciting, but I can assure you from the experience I have, you will be rewarded for the time you spend doing data collection and cleaning, because this is thanks to the fact that you got pricing, you got marketing, you got promotion, that you will be able to do a good forecast. Then the rest of the project, it's really pure data science, would be selecting the model, doing the fine tuning, and so on. Again, for me, feature selection is the most important part here, where you will do your best to feed the model with relevant information. And again, to conclude, do not forget to compare yourself to a benchmark. And for me, the best benchmark would be most of the time, but not always, a 6-month moving average. I think that's it for me. I'm very happy to discuss Q&A with you. I know I was super fast, but I had so many things I wanted to share with you. And as you know, I'm very excited about the topic. So please excuse me for going so fast. And pardon my French for the accent if that was of any issue with the English.
Yeah, thank you so much. I think that was highly informative. There was a lot of information condensed into a very small amount of time, but it was actually very, very well presented. We'll definitely be sharing the recording afterwards, and as well as the slide deck, so you have information, all of this. So yeah, let's use the rest of our time just to do some Q&A. Again, if you want to, you can message Nick directly and he can just go from there. And then also, if that's not possible for some reason, for technical difficulties, you can message DSML team, and then we can go ahead and relay it to Nick afterwards. And so with that being said, let's just do some Q&A to wrap up.
Yeah, so I received a lot of questions. I would really love to answer everything. I will answer maybe some of the questions that I can quickly solve. Some of you are mentioning as a KPI WMAPI, which is weighted MAPI. Weighted MAPI is a very complicated way to go back to MAE. So if you're using currently weighted MAPI, actually it translates to the same kind of KPI of MAE, except it's more complicated to explain to compute, so more prone to error. But also it's still undefined if you have zero demand. So overall, I would also not use weighted MAPI. You can directly go to MAE. It will just be easier for you. I also receive information concerning sales, how to deal with sales. So what's very important for me is if you just get sales and you know that you had a lot of shortages and issues, you should do your very best to also get information about shortages so you can start removing the periods with shortages. So it's also something that business leaders are very interested into, is to try to estimate the amount of lost sales. So meaning that you get a shortage, you have zero sales, but people are thinking, okay, but we lost opportunities there to sell products. Actually, you can use your forecast engine to do a forecast during this period with shortages to say, well, actually, if we didn't have a shortage, maybe we would have been able to sell, I don't know, 1,000 products because that was our latest forecast there. So you start having the opportunity as a data scientist to estimate the amount of lost sales. A lot of business leaders are very, very excited by this type of information. And I think it's very important to do that. Let me take a look at the other question. I'm receiving a lot of comments, so I'm sorry if I cannot answer everything. So someone is saying, is machine learning difficult to deploy at scale? I never had this problem with any of my clients, and I think more and more companies are using machine learning without any kind of issue. So this is for me not a problem. Someone is saying, how should we forecast new products? So new product is a difficult product. It's a difficult subject, forecasting new product, because you lack information, but also because you have a lot of different scenarios. I will publish an article on the subject most likely tomorrow and next week, Monday. So if you go to my blog and you subscribe to it, you will get an email in the next days with a full article regarding new product introduction, which is definitely a challenge for models, but for human as well. So someone is saying, is machine learning good for long-term forecasting? The answer is yes, it's really good for long-term forecasting. With machine learning, you can easily make forecasts 50 weeks ahead, 100 weeks ahead, no issue. What might be more difficult is to forecast per day and do a forecast for the next 600 days, but I'm not aware of a lot of models that are able to deal with 600 days ahead forecast by days. That's a bit difficult. Someone is saying, what would be the, from an academic point of view, what are the important subjects now for research? I do not define myself as a researcher. I'm more starting from the business needs, and then I try to come up with new solutions. I think some of the subjects I'm highly interested into nowadays are, how do you make sure that better forecast translates in better inventory? So how do you make sure that once you define inventory targets, inventory level, safety stock, how do you make sure that these are properly, like the size of these buffers and level are totally matching the expected forecast accuracy? I think there are maybe 1,000 different ways to estimate that. Once you get a forecast, how much safety stock do I need? And I think we need more research that are directly connecting forecast with safety stock targets. That'd be amazing from a business point of view. And again, there are, I think, 1,000 ways to do that. So there's really room for everyone to try out new models. I'm reading the question. I received so many questions. Just let me read that for some minutes and I'll reply. So someone is asking, could we also forecast inventory? That's not a very clear question for me, but something that's very important is to make the difference between what you plan for, what are your decisions, versus what's the information. So a forecast is a piece of information. You make a forecast about demand that you expect tomorrow, so the number of clients you're going to get, for example. But then you could decide to have a very high inventory buffer. You could decide not to take so much inventory because you don't want to have any waste and you don't want to take any risk. And that's totally fine. And for me, it's very important that we make a difference between these two. So there is really this decision, which is how much should we produce? And then there is the information, how much demand do we expect in the future? But the two are different for me, okay? Now, with machine learning, you have a limitation, and I received a few questions about that, is that you need data. Actually, I've seen models working with small data set where you would only have, for example, 3,000 products over a few years, and that might be enough. Now, if you have a business and you just have 15 products online and you just have 2 years of historical demand, that will not be enough to run machine learning. You will have to use statistical models. It's not so bad. It just means that you cannot squeeze already all this extra accuracy from machine learning. Nevertheless, this should not restrain you from using good statistical model to make a forecast. Someone is also asking, what kind of model would you recommend for machine learning when doing this forecast? It's a very good question. I see this is confusing a lot of people. We have more and more software vendors that add machine learning capabilities to their offering. I think it's a great idea because machine learning is great, but unfortunately it drives a lot of confusion because usually these do not work. And this drives people crazy. So the issue is that I think we tend to rely on the concept, and it's a massive confusion, that there is just one neural network or there is just one XGBoost, and that if you say to someone, well, I had this problem and I used XGBoost, it didn't work. If you say that to someone who's not a machine learning expert, it might sound like machine learning will never work for this thing because I tried machine learning and it didn't work. But actually, XGBoost is just one way of computing things, but you could feed different features, you could optimize differently, you could use it differently. So if I see someone saying, well, I use a neural network, it didn't work, it doesn't mean anything. It doesn't mean that another neural network could not succeed, and it doesn't mean that another machine learning could not succeed. So I would be very cautious about this confusion about very big generalization saying XGBoost didn't work. I had these software vendors, they tried XGBoost, it will never work on my data set. No, it's untrue. You could use XGBoost in a very different ways. Personally, nowadays, I'm using XGBoost a lot and LightGBN a lot. I'm not using neural networks for forecasting, but that doesn't mean anything. I'm absolutely sure you could do amazing neural networks to forecast demand. Someone else is asking some extra question regarding KPIs. So as said, I think looking at the combination of MEE and bias, it's really the best because it's a very good compromise between accuracy and bias. It's very easy to explain and so on. The way I compute it, I simply take the MEE value, you see here 68%, and I add the bias, but I just need to add the absolute bias. Otherwise, if you get a negative bias, you get a negative score. That's not a good idea. So here you see MEE plus bias, I just sum up the two values and I get this 68.9%. I call it the score, but feel free to call this anything you like, as long as it's clear for your colleagues, okay? So I also received some questions concerning the future. How do we take into account the fact that promotion can change, prices can change, the marketing plan and action can change? And that makes sense, right? If you're a business and you see you're below target or you have too much of a specific good, you're going to start to promote it maybe tomorrow. And it means that when you made the forecast 2 or 3 months ago, you were not aware that you would do this massive promotion. But in terms of business, you said, well, I have this pile of goods and I need to sell them, so I'm just going to launch a promotion tomorrow, even if it was not included in my forecast. I don't think it's bad. Again, the forecast, you're just showing information, but then if someone wants to make a decision that you really need to get rid of some stock and you need to do a promotion tomorrow, it's fine. It's a business decision. It's totally great. There is no issue with that. But I don't think your forecast should be armed for that, and people should complain that your accuracy was poor. Of course, it was poor because people decided to do a promotion that was not planned initially. But I don't think it's bad, as long as it's very clear that it's not your fault if the forecast is wrong. But it's very important that business is able to drive decision. Okay, we're here to support business, not to tell them, okay, you need to plan promotion 3 months in advance. Now, to go back to another similar question, how can we deal with prices? Prices are very difficult to include in models Why? Because most people don't know future prices. So let's imagine you have a business with 1,000 different products in 20 different countries, 20 different states in the United States. If I ask you, can you give me the price of every single of these products for the next 12 months in every single state or country? It's for sure you will say, well, I don't have this info. You also have to take into account that businesses and supply chain have different sales channels. Different sales channels means different prices. So it's not just 1,000 product times 20 country. It might also be times 3 sales channels. So it's nearly impossible to give future prices. You never know how inflation is going to behave. So if you include prices, you could just feed historical prices. So at least the tool knows that, well, demand has been impacted by recent price changes. That's already great. You could also decide to do scenarios about prices. For example, scenario normal, you keep prices constant. Scenario 1, you say, well, we increase prices by 2% and we see what happens. And then you start to do some scenarios. But of course, you know that maybe if today I do a forecast for September, by September, prices will be different. And that's, again, normal, and no one can blame you for not getting that right. And someone is asking about the recording. We'll do our best to put it on YouTube in the following weeks, but I'm not sure I will share the slide. We just need to discuss that. Someone is asking, yeah, so something I didn't discuss much is this forecastability exercises. If you want to assess the forecastability of a data set, a lot of people in the past used to use this coefficient of variation, the standard deviation of demand. I didn't discuss this much, but I'm actually against that, because for me, these are not forecasting techniques. Instead, I was always rely on, let's try to find a good benchmark and let's compute the forecasting accuracy of the benchmark so we can compare ourselves to a benchmark. Again, a good benchmark is just a moving average 6 months or maybe 12 months or 3 months, nothing complicated. And this might give you some very good results. And it's much more fair than computing demand standard deviation. I think we're gonna touch 1 hour, so maybe I'll just reply to one last question. I receive at least 2 or 3 questions regarding COVID. I'm still surprised this is still a topic. So for me, COVID should be basically bypassed, a bit like the shortages we've just seen. So depending on your business and country, you could just simply say, you know what, I'll take my statistical engine and I'll just say I will bypass, I don't know, March, April, and May 2020. So I'll just bypass the big hit of the COVID. And then as of then, I just start to forecast again and it should work. That's one way of dealing with it. I think it's the easiest way and it should work with most people. Alternatively, in machine learning, you can add COVID as a feature. So I'll just go back to, sorry. Let me share my screen again. You should just add back this feature in your model, so you make sure that your model is aware that something with COVID is happening. So here I would add a feature that would be called COVID true false, and that would just let your model know if COVID is a thing. I think we can stop here. I hope you enjoyed the discussion. I hope I could give you some extra insights. Feel free to follow my blog if you want more information. The next article will be about these new products. You can also follow me on LinkedIn. I'm trying to share a lot of ideas if I can. In any case, if you have more questions, you can always feel free to contact me by email.
All right. Yeah. Thank you so much, everyone. Let's give a round of applause for Nicholas. I think that was an extremely informative hour, and so definitely enjoyed just the really applied insight into kind of like this super important like subdomain of data science. So I thought it was awesome. So Nick, thank you so much for being here. It's greatly appreciated. Everyone else, yeah, we'll make sure the video recording is sent out afterwards. So if you want to go back, actually, no, I would like to go back and kind of look at this, things like that, make sure I absorb everything inside of it. And so I think you have Nicholas's contact information. If you don't, for some reason, feel free to get a hold of us, and then we can forward anything. Like if you don't mind, people have additional questions or follow up. We can also help get you in touch with him if you need some additional help. So awesome. So Great. So just everyone, thank you so much. We're gonna wrap it up here so we keep everything time boxed. Just as a quick heads up, so I know we have some new faces here. We try and have these sorts of events on a weekly basis. And so obviously, you know, Nick's like a rock star in supply chain optimization, right? And demand forecasting. But we actually like to make sure we have a regular dose of just different people on their particular domains of expertise. And so just as a quick follow-up here, for future information about soup other events, you know, we have additional channels. You know, we do Eventbrite, we do Meetup. We also do some things through Codesmith as well. But the ground source of truth is our website, dsmlresearch.org/events. And that's kind of where we keep our consistent lineup going. That's ground source of truth. So we'll have new things coming up. And again, if you have any additional questions about how we could help you, again, either with, you know, again, developing, basically transitioning into the domain of ML, if you're a STEM academic, or if you need help with some of your own, you know, technical problems, please feel free to go ahead and reach out to us, info@dsmlresearch.org. And just one more time, everyone, let's extend a huge help out. A huge round of applause to Nicholas. This was just like an awesome talk, awesome event. So thank you so much. And then
It's really my pleasure. Thank you.
Thank you, everyone. Bye-bye.
Ciao. Have a great time. Bye.
Thank you.